Alright, this is for the students who were unable to or didn't show up for the review session at lunch. This is the review for the anchor for the real number system. It was, not EE, sorry, it was 8.NS and 1 and 2. Okay, number system, that's my fault. Got so used to writing EE. Alright, rational numbers, and I'm going to go pretty fast. You can always stop, slow down, rewind, but I want to be able to get through this. Rational numbers can be written as fractions, or another word for that is a ratio. Okay, first 5 letters of the word rational is ratio. Okay, as a decimal, they either end, or another way of thinking that is stop, or they repeat. They have a digit or a set of digits that repeat. And you can see the repeating either by having a set of digits here that repeat with a dot, 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 or with what's called a repetend or a line over what repeats. As a square root, to be rational, they are perfect squares. Okay, so when you take the square root of them, they become whole numbers. Irrational numbers cannot be written as fractions. As a decimal, as a fraction. As a decimal, they never end and they don't have a repeating pattern. And how you would see that is a set of numbers that have no pattern to them, dot, dot, dot. Okay? One of the most famous irrational numbers is pi, and anything you do to pi would be irrational. So if you add, subtract, multiply, or divide by pi or 2 pi, it will be irrational. As a square root, irrational numbers are non-perfect squares. So if the number underneath the radical, it's called a radicand, is not a perfect square, then it is irrational. Okay. Integers are positive and negative whole numbers, including 0, whole numbers are positive including 0, and natural numbers are counting numbers. So basically whole numbers without the 0. Okay? So we're going to categorize numbers based on these. First, we're going to take a set of numbers and just determine whether they're rational or irrational. Okay? So number 1, 3 and 4/10. That is rational because it ends, it stops. Number 2, 8.2536 dot, dot, dot. There's no digit or set of digits that repeat, and it never ends, so that's irrational. Number 3, -5, it ends, so it's rational. Number 4, the number 0, it ends, rational. Number 5, the square root of 43. 43 is not a perfect square, therefore it's irrational. You may want to write your perfect squares down at the side of the paper. 6/7 is a fraction, therefore it is rational. The square root of 144. 144 is a perfect square whose square root is 12, therefore that's rational. And 0.64 repeating would be rational. Alright, classify the following using A through F here. Well, all of them are real. All of them are in our number system. We all could use them within our reality. They're all real. Next, we're going to determine whether they are rational or irrational. Okay? -7, 4 and 72/100, it stops, therefore it's rational. And then if it's rational, you need to continue on here and determine whether it's an integer whole or natural or all 3 or just maybe 2 of them. But because all of these are positive or negative whole numbers, they have nothing after the decimal point, and we have two numbers after the decimal point, we are finished. We can't categorize it any further. All right, square root of 81 is real. It's also a perfect square whose square root is 9, so it's rational. Now we go on to, since it's rational, we go on to see if it's an integer. It is a positive or negative whole number including zeros, so it's an integer. It is a whole number, and if I started counting, I would count to 9, so it's a natural number. Oops, this is my fault. I was supposed to, and this one as well, B, no C, D, E, F. My fault. All right, negative 5, 6. It is written as a fraction, therefore it is rational. But if I divided that out, I would get a decimal. It's not a whole number, it's a fraction, so therefore I'm done. I can't categorize it any further. 72, not a perfect square, therefore this is irrational, and anytime you have an irrational number, it cannot be categorized any further, so you are finished. All right, turn it over to the back. Repeating fractions into decimals. To change a repeating fraction into decimal, you write the digit or digits that repeat on top and the same number of nines. Sorry. Of nines on bottom. Alright, so here we have 2. 2 is what repeats, so that goes in the numerator. It's one digit repeats, so 1 9 in the denominator. It cannot be reduced because we're going to write our answers in simplest form. Alright, 4 5 is what repeats, that goes on top. The same number of nines on the bottom, so 99. This can be reduced, and I know that because 9 goes into 45, and I know 9 goes into 45 simply because I know that it does 5 times, but the digits 4 and 5 add up to 9, therefore 9 must go into that. I can divide top and bottom by 9, and that gives me 5 11ths. Make sure you reduce. Number 3. We're going to write the 3 digits, 2, 1, 3 on top, the same number of nines in the denominator. I'm going to check to see if either 3 or 9 can go into the number. 2 plus 1 plus 3 is 6. 3 goes into 6, so 3 can also go into 213, and 3 goes into 999. 3 goes into 21 7 times, 3 1 time. And 3 goes into 999, 3 times, 333. And that's our reduced answer. All right. Estimating non-perfect square roots. You find the two perfect squares that the non-perfect square root is between. Determine if it's closer to the smaller or less than or the larger half than. And I don't think that that's actually going to be on the anchor, but it's good to know. It would be helpful if we knew our perfect squares, so that we can have our perfect square roots. So the square root of 1 is 1. The square root of, I should write that differently. Square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. And I'll just keep going here. Sorry, I was thinking 8 because its square root is 8. Alright, so let's see which two whole numbers the following between. Square root of 73. 73 becomes between 64 and 81. Therefore, this comes between 8 and 9. Square root of 18 comes in here between 16 and 25, whose square roots are 4 and 5. Square root of 32 comes between the square root of 121 and 144, whose square roots are 11 and 12. Square root of 92 comes between 81 and 100, square root of 81 and 100, which would be between 9 and 10. Right, pi is approximately 3.14. So if I add 5 to that, that's approximately 8.14. So that's between 8 and 9. Again, pi is approximately 3.14. So if I multiply that by 9, or excuse me, by 3, I'm going to have 9 point something. So then it's going to be not between 9 and 10. I don't need to figure out exactly what it is. Alright, lastly, placing the numbers on the number line. I should have labeled these. I'm sorry I didn't. This is A, B, C, D, E, F, and G. Okay? Excuse me. Alright, A, 14 halves, 14 over 2. The fraction bar is division, so that's 14 divided by 2, which is 7. So A goes here on 7. B, the square root of 11 is between 9 and 16, which is between 3 and 4. It's closer to 3, so B would be approximately right there. C, 5.3 is just a little bit less than half, so it's approximately there. D, pi is 3.14, so 2 times 3.14 is going to be approximately 6.28, which is about right here. E, the square root of 36 is 6. So E is going to go on 6. F, 3 squared is 9. And then last but not least, G, 1/4. 1/2 is about right there, so 1/4 is about right here, which would give me G. The retake for this is Tuesday during IE. You need to let me know that you're going to retake it so that I can sign you up.